Hi everyone, welcome to the channel. Today we'll be looking at this problem called hand of straights. And Alice has a hand of cards given as an array of integers, and she wants to rearrange the cards into groups so that each group is size W and consists of W consecutive cards. Return true if and only if she can. So we see here is the hand and W equals 3. And we have 3 groups, each where there are 3 elements in the list, and they're all increasing by 1, so they are straights, and it has been built with all the cards in the hand, so that's why it returns true. On the other hand, we see here we have 5 cards and W equals 4. We automatically know that this is not possible because you can't divide 5 cards into groups of 4 evenly, and so that's why false is returned. And the main idea for this problem is that we make a dictionary to keep track of each card with a certain value, how many counts that we have in the hand. And so for instance, we take a look at this. We make a dictionary. We have 2 2s. And the number of 3s that we have are also 2. And then number of 6s that we have is 1. And for 4 we have 1, and 7 we have 1, and also 8 we have 1. Yeah, so all the stars just mean that I've already taken these into account. Now the next step is, since we want to build these straights and want to see if it's possible, we need the smallest card first. And so we could heapify the dictionary. Well, we heapify the hand, and that will yield 1, 2, 2, 3, 3, 4, 6, 7, 8. And so each time what we do is we take the smallest element from the heap. And so in this case we have 1, and then we build a straight. And we know that W is 3. So that means we check 1 plus 0, 1 plus 2, 1 plus 3 in our dictionary. And so we use 1, so then we decrement our dictionary to 0, and then we check 1 plus 2, which, well, sorry, it's 1 and 1 plus 2. So the next one in our straight is 1 plus 1, which is 2. We check in our dictionary, it exists, and we decrement, we use it. So we have 1, 2, and then we check 1 plus 2, which is 3. It's in our dictionary, and we decrement it. So now that we finished that, in our heapify, when we chose the 1, we popped it. And so now we choose the second smallest, which is 2. So once we have 2, we start our next set. And for 2, we decrement, we see it's there. And we do 2 plus 0. We check for 2 plus 0, 2 plus 1, 2 plus 2 in our dictionary. So 2 plus 1 is 3, so now it goes down to 0, and then next number is 4, so that goes to 0. And then since we already popped this, now we have 2 again. Now once we have 2, we check in our dictionary, we see that it's 0. So it means that we don't have any of these any cards of this value left in our hand. So it means we need to check the next one in the heap. So then we check 3. Also the same scenario. 3 has 0 in our dictionary, so it means that we don't have any of these cards left in our hand. And we see the next 3, and it's the same story, and also the same story for 4. So then we continue to pop those, and then we see we have 6, and this one does not have 0. So that means we continue to check 6 plus 0, 6 plus 1, and 6 plus 2 in our dictionary. So once we choose 6, we decrement. And then 6 plus 1 is 7. We see 7 now in our dictionary, and then we decrement. And then we see 8 in our dictionary, and we decrement. Now, it'll be a similar story once we check 7. We see in our dictionary 0, so we cannot choose that one. Then we see 8. It's in our dictionary, but it's 0, so we can't choose that one. And we're finished iterating the entire heap without returning false. And so we can return true in this case. We see we've built 1, 2, 3 straight, 2, 3, 4 straight, and 6, 7, 8 straight. So now that we have the main idea illustrated, let's proceed and continue to code. Now, few things to notice is we're using a default dictionary and we're using a heap PQ, so we have to import those first. So, real quick, from the collections, we'll import default dict, and from heap PQ, import heap pop, because we need to pop from the heap to get the smallest element and build our straights. And we will need heapify to get the proper order of our hand, which is this. Oh, right, it used to be here, but the array got consumed. All right, well, for starters, we have a few edge cases. One is if, well, first let's get the length. We calculate the length equal to len of hand. And if the length, like in example 2, if the length mod w is not equal to 0, then we return false, because we are not able to divide all the cards in our hand evenly into groups of w. So it's not possible to have straights with all length w. Another edge case we have is if w equals 1. Now, if w equals 1, we automatically return true, because if we want groups of 1, any number of cards that we have in our hand, they could all become groups of 1, and it would be a straight of 1. So it would be true. Now we have to construct our dictionary, this dict right there. And so to initialize it, dct, default dict, and we will have a bunch of integers. And then all the cards in our hand, we will use the key. The key will be the value of the card, and then we will do plus equals 1 to keep track of how many of those cards that we have. Next step is to heapify, which is that step we did here. And then we take before we take the smallest element, we want to perform these operations for each of the straights that we have. And the number of straights that we have is length divided by w. Now, start is our first card in our straight. However, it is possible, like we saw before, where the dictionary has a value of 0, meaning we run out of those cards. So we need to pick up the next smallest card if that is the case. And we do that by popping from our heap, so removing that element and then getting the next smallest. Now, to do the 1 plus 0 plus 1 plus 2, we are iterating up to w, and we will be adding to our start value. First is we use the card. So to use the card, we do minus equals 1, indicating that we use the card. And if we have 0 and we use the card, it means that we have no cards and we try to use the card. That's how we get -1. And so in that case, we return false, because this means that we need a card to make a straight, but we are unable to use that card because we don't have that card left. The next step is to do start plus equals 1. And so we see here start would equal 1, for instance, and then w, the range would be 0 up to 3. Let's say w equals 3. So we do plus 0. And so if we do plus equals 1, then the next card we would find the card of value 2. And if we're able to build with all of this, then we return true. Yeah, let me take a look at the code and make sure things are good. So from collections, import default dict, heap-eq, import heap-pop, heapify. Okay. First, we calculate the length, and then length mod w not equal to 0, return false. Case where we just want groups of 1, create our dictionary, and then populate our dictionary. And in hand, yes, that's correct. Heapify the hand, and then through each of the groups, number of groups that we have, number of straights that we have, length divided by w, get the smallest from heap pop. If that is 0, we continue to find the next smallest until we continue to find the next smallest card until we find one that has at least one card within the hand. Then with the starting value, go up to w and look for a straight. So if w equals 3, start equals 1, then we will look for start, which is, if we say it's 1, then it would be 1, and we look for 1 plus 1, so if we look for start equals 2, and then start equals 3, so that's what this plus equals 1 is, and then we first decrement our dictionary, minus equal 1, meaning we've used the card. Okay, so that looks good to me. Let's see. Submitting over. Okay, compile work. So it looks like indented block. Okay, I think it's this, yeah, this comment area. That's probably what's causing an issue. All right, let's see if that's good. Awesome, so that's good. Let's talk about runtime and space complexity. So our space, because we make this dictionary, and let's say we have n elements, in hand, then space is O of n to complete create dictionary. And the other thing is, the other thing is, well, it also takes O of n time to create the dictionary. Then heapify takes O of n log n, and O of n space complexity. And then for the number of groups, the for loop, we have O of n over w times w, which ends up being O of n. And so we're summing these three, And so the runtime that runtime is O of n plus O n log n plus O of n, which in big O notation, the dominant one that takes form is O of n log n. So that's the final runtime, and the space complexity is O of n. So yeah, thank you guys for watching. I hope you guys learned and had as much fun as I did. If you would like more content, please like and subscribe and follow me on social media. And also enjoy the rest of your day. Thank you.